Alright, quick little review of Chapter 6, Section number 1. We are solving systems by graphing them. So you're just going to graph lines. We're going to start with -3 down to -3. We need rise 2, run 1. Rise 2, run 1, rise 2, run 1. To be more accurate, we're just going to ride that slope out just a little bit. So we have -1. And this time the slope is 1/1. So we rise 1, run 1. So there we found the point of intersection already. So if we just connect our points for those lines, here's what we're after. So that is 2 paired with 1. We included a lot of vocabulary to deal with what can happen. So if I have two lines with different slopes, that means I'm going to get one solution. We call one solution consistent independent. Remember, one is someone that can take care of themselves independent. If we have parallel lines, that means the slopes are the same, the y-intercept is different. We call that no solution, right? Because they're never going to share a point, and that's called inconsistent. And the last one, if we end up with the same line, that means the same slope and the same y-intercept. They share all the points, so the solution is all the real numbers, and that is consistent dependent. So those are the emphasis that we're talking about. So again, all we can do is rearrange some of the equations. Right, so here we made you distribute the 3, but then it's still in slope-intercept form, so not too bad to work with. Some things to review here. If it is just plain old y, remember you can add y. So we get y equals 3x, it would be plus 0. So that gives us a y-intercept. And let me scroll down here. Very common on your standardized test. They want to rearrange these. Remember, b is the 8, m is -1 here, and b is 4, and m is -1/3. Okay, you don't want to get stuck in that rut. Say the first thing is the slope. Remember, it is the coefficient on the x term. So you're going to start with that 8, using -1 for a slope. So that'll bring this line down. Same thing with the 4, down 1 over 3. And we continue in that fashion until we find 6, 2, consistent independent, where they meet up. Horizontal line with a y equals -3. So we know right away part of my solution has to be -3. And then if we just subtract 4x, probably the easiest way, if we do an intercept, we're going to find that x is 1/4, which is pretty hard to tell exactly what's going to happen from there. Classification. Okay, so when we look at this bottom equation, so one thing you want to keep in mind, if I'm doing 3x equals 9, x equals 3, so it gives me an x-intercept of 3. Same thing happens with the y. So we don't want to rearrange everything unless we really, really have to. So we get to connect those two. Probably with the top equation, if you want to use a y-intercept of -5, that works. So if we use 2x equals -5, the x-intercept is -5/2, which is -2.5. So we can connect those. In this, again, since it was 1y, probably easy enough just to subtract the 2's, so we don't have to guess about where 1/2 is on the graph. Okay, I believe this one ended up -8 with +11. If we check them in the equation, we'll find out that has to work for both of them for that to be the solution. Alright, then we had our exit pass on the way out. So really trying to review what's happening here. Graph the two lines, find the point that they cross. That's the number one thing. And then identify the vocabulary as we go. So luckily these worked out pretty nice. So that's going to be the whole thing. And then later in the chapter we'll start doing this algebraically.